So what we're going to talk about today is distribution of data and, specifically ways of drawing out our data or displaying data, dot plots, box and whiskers, histograms, and then we're going to look at how the types of distributions, skewed left, skewed right, or if it's a normal bell curve. Those are the things we're going to talk about. So first off, let's talk about a dot plot. What a dot plot is just like if I had a number line going, I'm going to look at my data and for every value here, I'm going to put a dot above the corresponding coordinate on my number line. So in this case, I'm going to put a dot at the 1, I'm going to put a dot at 2, at 3, at 3, at 4, and another one at 4, at 5, at 6, 6, and 6. There's 3 at 7, 1, 2, 3 at 7, and then 1 at 8. And that's all a dot plot is doing. Now, if you look at it, you can sort of see that the data is more on the right than it is on the left. Well, I like to call this is what we call more of a left skew data, okay? And the way you sort of remember that, if you look at the back side of your hand, and your left hand starts small and it goes up and then it comes down. So that's left skew. You look at the back side of your hand and your right hand. And if you notice, it goes up and then your fingers start to fall off. Well, that's what a right skewed data would look like. It goes like that. Now, normal is like this. If you just hold your hands like that, where it goes up and then it comes down. It's very uniform. It's shaped like a bell. We call it a bell curve. So that's a normal bell curve. So in this case, if I had to say this would be a left skewed data. I always have to look at my left hand. I'm left-handed, but I always have to look at left just to make sure. So this is a left skew. Okay? Now, when we're talking about a scatter plot, what it does is if I have my data, again, I'm going to make sure that the median number is right here in the middle. Well, over here, my median number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 pieces of data. If you divide that by 2, it's going to be 7.5. So 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. The one that's in the middle, 7 below it, 7 above it, would be my median. So in this case, my median would be 5. So I would put a 5 right here. Okay? The lowest value is what we call the minimum value. So the minimum value would have been a 1. So that would be a 1. So I'd put a 1 here. The highest value was an 8. So I would put, oops, I'm going the wrong direction. So I would put an 8 here. Now these are my quartiles. This is my lower quartile, which is called quartile 1. This is my upper quartile, which is called quartile 3. Quartile 1 is going to be halfway between. So now I have 1, 2, 3, 4, 5, 6, 7. Well, 7 divided by 2 is 3.5. So 1, 2, 3 below, 1, 2, 3 above it. So right there would be my quartile 1. So that would be, oops, going the wrong direction again. This would be a 3. The quartile 4 would be the same way. I'm going to go 1, 2, 3, boom, 1, 2, 3. And so it would be, what did I just circle? A 7. Well, what does that mean? It means 25% of my data is going from 1 to 3. 25% of my data is going from a 3 to 5. 25% is from 5 to 7, and 25% is from 7 to 8. So it's breaking it up into quarters. So it's telling me the range of each quarter. The inner quartile range is going to be from 3 to 7. That's from this value to this value. And then my range goes from the minimum to the max. Okay? Now, We can also do what's called a histogram. On this, the histogram, what we need to do here, let me make that small, is I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. These are my values that I can have. This is going to be the frequency of them, okay? How many times do they occur in the data, okay? How many times do we actually have them occur? So I have 1, 1. So in this case, I'm going to put a 1 right there, and I'm going to put a bar like that. I have 1, 2. So I'd put 1 right there. I have 2 3s. So I would do like that. I have 1, 2 4s, and I have 2 5s. I have 3 6s. I have 3 7s, and I have 1 8. So if you look at it, this is very similar to that dot plot, except I'm using bars, okay? I'm going to use bars on this. And it does show my distribution well here also. Now, when we're talking about distribution, the reason why it was left and right, if you look at this one, this was what we called our right. That's because here is our mean, okay? And our mean is to the right of our median, okay? On this one, this is a left skew. Well, why? Because the mean is to the left of the median. This is our mean, and this is our median. And in this case, when it's left skewed, the mean is to the left of the median. When it's this wonderful bell curve or a normal bell shape, this is what we like. Our mean, our median, our mode, they're all in the center, and this is very symmetrical, okay? These aren't as symmetrical. Whenever we have skewed data, that means sometimes we want to use our median over our mode, or our median over our mean. If you're thinking about the population of the whole entire United States, you know, there's times we don't want to do the mean. We want to deal with maybe, because we don't want to add the Bill Gates of the world in there, you know, all of these uber millionaire, billionaires, the Sam Waltons, the Bill Gates. We don't want them added in there to pull the mean out of the way, because here it would be pulling our mean, because we have what's called outliers, and these outliers here are pulling the mean away from the median and the mode. So down over here, they're actually pulling the mean. Here, you know, these smaller numbers are pulling our mean away from our median, our mode. So there's times when we want to use a median over a mean, especially when we have outliers or we have these numbers that are really throws things off, okay? So when we're using it, sometimes we like to use the mean, but other times we like to use the median to explain. And if you ever look at data, a lot of times you need to really watch, because they will use median. They use a median income when we're talking about the United States instead of a mean. They use a median when they're talking about, heights and stuff like that. But we also talk about averages, like the average temperature of somebody. It's because there's not really that many outliers when it comes to body temperature. So, you know, you have to be sort of careful on your means and your medians. Which one do you want to use to describe your data? I hope this helped a little bit, and I hope you remember a lot of this from when we talked about it in class. Y'all have a wonderful, wonderful day.